Good morning. Here I am Kanal Majumdar. So this is the demo video for the PGT post of physics. Today I am going to discuss laws of motion. And first, if I write laws of motion here, laws of motion is basically a class 11 topic. So okay, it's a class 11 topic, but you all of the students have studied it in a class 9. Okay, everybody knows there are the Newton's three laws of motion and three formulas: S, V, U, and that is T. What is the distance time relation? That is distance or displacement difference or acceleration velocity difference, whatever the relation or the difference may be. But today I am going to discuss the laws of motion in a very narrow way, in a very small topic. Everybody have gone through lift, right? So everybody knows what is lift. Everybody knows, right? From going to a down floor, from ground floor to higher floors in a shopping complex or in a shopping mall or in tall buildings, just like in movies you see, like in California or in New York City. From in higher cities or developed cities, from going to lower floor to higher floor, we use lift. So today I am going to discuss the motion. Today I am going to discuss the motion in a lift. Okay, today I am going to discuss the motion in a lift. So every time you stand up in a lift, you feel something like so much pressure in your heart, like am I going upward with so much of force? This is because the your apparent weight. Whenever you stay inside a lift, it goes upside or downside, you feel such an uncomfortable situation with your weight. You feel sometimes too much heavy, sometimes too much lightweight. So this is because the reason of the apparent weight. Okay, this is because of the apparent weight. Okay, you know what is weight. You only know what is your weight only. That is given by mg. Okay sir, from class 9, from class 10 I have learned this. This is weight equals to mg, weight equals to mg. What is the Newton? What is this one? What is apparent weight? Okay, let's see. You know your weight is mg. Okay, you are inside a lift. Here you are enjoying with a chocolate. Okay, but when you are in a lift, a force is acting on you downwards, that is mg. Okay, a force is acting on you downwards, that is mg. And something, you know the laws of motion and also the laws of Newton. The third law of Newton told what? The every force have an opposite or repulsing force. So if it is mg, there will be another force which will minimize it, try to minimize it, that is T. Sir, I only have felt mg, never the T. Because the T, that is the tension. That is the tension not felt by you. It is felt by the cable or the wires attached to the lift. Felt by wire. Okay, felt by the wire, or you see, you can say cable. But sir, all thing I know, this is lift, this is tension, this is mg. Okay, but sir, what is the apparent weight? Here the term T, whatever the change the term T face, it will be considered as your apparent weight. Let's see. In the first case, when you have just entered into the lift. That is case 1. Just entered into the lift. The lift is not moving upwards, neither downwards. Okay, you have just entered and just waiting for few more people to enter into it. That is, lift is at rest. Okay, so what will be the mass, what will be your weight? Then your weight will be T equals to mg. Here the T, this term T, this gives the idea of apparent weight. This gives the idea of your apparent weight. Okay, so now you will see, okay sir, this is the just same, just as you said, this is the weight, this is the apparent weight, this is just same term. Why there is no change? Wait, because the lift is at rest, there will be no force. It is not going upwards neither downwards. That is, T minus mg equals to 0. That is, whatever the tension is, the mg is also the same. That's why there is no force acting on this side to disbalance it. Okay, now what happens if you go upside? That is case 2. Lift is going upside, you are going upside. Okay, from just like from ground floor to second floor, you just enter and then press the button from ground floor to second floor. Then what happens? Then the whole lift moves with an acceleration, that is a. So now which one is bigger? See, T, between T and mg, which one is bigger? T, obviously T must be bigger, because T is acting upwards and the lift is also going upwards. So now T minus mg, that will be equals to ma. Now if I look at T, that will be mg plus ma. Oh sir, this is our weight and this is something extra. For this extra term, you feel a certain discomfort while going from down floor to upper floor. This is the reason. Now this is the apparent weight. So apparent weight is greater than your actual weight. This is the same. That's why you feel the discomfort while going from ground floor to upper floor. Now if you see what happens, what will happen in the same case? What will happen if you go with the same acceleration, with like the acceleration due to gravity? That means your A becomes G. What will happen? Then what will happen? Now wherever there is A, you can put G. Wherever there is A, you can put G, right? So from this you can write, right? You can see T equals to twice mg. Okay, here T equals to twice mg. That means apparent weight becomes twice of your actual weight. My God, you are double of your own weight now. When your acceleration becomes equals to the acceleration due to gravity, that is A equals to G. Only if A equals to G. Now, okay sir, you have discussed in 3 cases. Now why I feel discomfort while going downwards? I feel something like very light, right? So now let's consider the case 3. Now lift is going downwards. Lift is now going downwards. Now try to solve it. What will happen now? Now, which one is larger? Just tell me. Between this, mg is acting downwards, t is acting upwards. Which one is better? Which one is more powerful to bring it lower? mg is more powerful. So, what must be greater? mg. What do we subtract? The lower one from the higher one. mg is higher, then lower will be t. And now this is not going upwards, this is going downwards. So now mg minus t equals to m. Now t equals to mg minus m. Okay, see, this was your actual weight. This was your actual weight, but you are subtracting something from your weight. That means you are feeling lightweight. This was your what? Apparent weight. So now your apparent weight less than actual weight. That's why you feel the discomfort while going from higher floors to lower floors. You feel something light. I am feeling light. I am very much light. Okay. So these are the 3 cases of the motion in a lift. This is also included in the chapter laws of motion of your class 11. Okay. So everybody says that like physics is so much hard. But see here, if you understand with all the logics, can you say it is very hard? No, obviously no. It is very easy. So one more short trick. Why short tricks, sir? Everybody remembers physics through short tricks. No, smart people. Only smart people remembers it through short tricks. Let us try. Why? Sir, this much of drama all for this? No. You have to learn only F, B, D. That is what? That is the free body diagram. Now, here you don't have to draw this hero. You are the hero. Here you have to only draw 2 portions. That is mg and another one is t. You have to find which one is acting on which side. If t is acting, so t must be greater. That means acceleration is upwards. T is more powerful, right? T is more powerful, so it is pushing it upwards. So T minus G will be ma. Now if mg is more powerful, mg is so hard, like it is trying to pull it down. So if mg is t, then mg greater than t, then mg minus t will be ma. See how much simple. In class 11, at least 3-4 marks you can expect from this topic. Okay, not only this is very much important for your NEET and GW also. Okay, so just see, if you think logically, honestly I say it is very easy. Okay.